The Authorization Code Grant is a kind of combination of service accounts and user accounts. It's a way of creating finer grained access control to the API. And one of the main reasons we use APIs rather than just raw databases, for example, is that we can create these compounded rules, these fine grained rules. Now, when I talk about a service account, I'm talking about things like an app, maybe an Internet of Things device, but it's an automation. And then when I'm talking about a user account, I'm talking about a human being, a person who's interacting through a UI of some sort, like a web browser or that app. Now, obviously, there are different ways people use these terms in the industry. So this is a very high level view that isn't vendor specific in any way. The service account has a problem. And the service account's problem is that it really only has one way to authenticate, which is by using that client ID and secret, which looks really fancy and programmatic and hard to do anything with, but it's really pretty much just a username and password that's hard for a human being to glance at and remember. Whereas a user can use a username and password or can use an OTP code that gets sent to them or some other form of multi factor authorization or even biometrics like a thumbprint or, I don't think we're really doing retinal scans anymore, but that sort of thing. And we also have physical keys like USB keys, UB keys, things like that. There are lots of ways to make sure this person is the person that they say that they are. Whereas if somebody steals that client ID and secret from the service account, it's pretty hard to know whether that's the service account or not. Now, what we have in the flow, and this is a high level grant flow, is a person who wants to interact with an app that needs to interact with an API, and then there's some authentication in the background. So the person opens up the app. The app immediately has to say, oh, okay, where do I send this person to authenticate them, to find out that they're who they say they are? The API should know that and should also know whether or not the app keys are still valid. And so if everything's okay, sends a URL back to the app, which relays it to the person, which immediately bounces them back to that login service. The login service is now going to verify them with whatever forms it has to do that, and then check with the identity service. And if everything's cool, sends back an auth code. This authorization code is what we're talking about. This code now identifies this person without having to reveal any username and password or any other authentication stuff to the app or even the API. Then we bounce that code back to the app, which sends it to the API, which can now check. Once again, I'm going to check that the client ID and secret is valid and that it matches that code, and then verify the code against an identity service. Now, again, different vendors do this different ways, but the idea here is that if you reach out to a third-party identity service, then you can mix and match identity services, which happens more often than you might want to believe. So then the identity service returns attributes which get put into the token. This is an access token. Preferably in an OIDC flow, it's going to be a JOT. And that JOT is going to now have that information in there about the user and the app, possibly. So, for example, we may have rules about accessing the API from mobile devices, and the app keys say that it's a mobile device. So we may not allow someone to access certain things. At the same time, the app keys, the client ID and secret, aren't associated with administrative roles, but the user is. So we add those roles to the description in this JWT that we send. And this idea of being able to combine roles and combine permissions to either grant more access or restrict access based on the two parties, the service account and the user account, is kind of the heart of why we use the authorization code grant in OAuth and OIDC.